Assalamu alaikum everyone. My name is Engineer Shahid Iqbal and I am lecturer in Mechanical Engineering Department, Engineering College, University of Wa. I welcome you all to today's lecture on refrigeration system. In this lecture, we will be exploring the principle and working mechanism behind refrigeration system. So these are the contents of our lecture. Introduction, refrigerants, application of refrigeration systems. Then we will discuss about the refrigeration cycle, ton of refrigeration and coefficient of performance of refrigeration system. Then we will discuss about the pH chart. pH chart stands for pressure enthalpy chart. And at the end, we will discuss about the environmental effects of different refrigeration system. So the refrigeration is an essential technology that has an important role in our daily lives. For example, the preserving and cooling of foods in a refrigerator. So understanding of refrigeration system is an important for the engineers, particularly in the field of mechanical engineering, thermodynamics, and energy system. So what is refrigeration? Refrigeration can be defined as the process of removing heat from a substance under controlled conditions. So these control conditions is actually stand for pressure, temperature, and humidity of the indoor conditions and outdoor conditions. Where the indoor conditions are the temperature, humidity, and pressure of the confined space, and the outdoor conditions belongs to the pressure, temperature, and humidity of the atmospheric air. So the process of reducing and maintaining the temperature of a body below the temperature of its surrounding is also known as the definition of refrigeration. Refrigeration systems, there are the different refrigeration systems. Here are the few different types of refrigeration system. The first one is vapor compression refrigeration system, vapor absorption refrigeration system, ice refrigeration system, and air refrigeration system. So here are the application of refrigeration system. There are different refrigeration systems that are used in different fields. For example, in food industry and chemical processing industry, process industry like textile and printer works. So industrial cooling in chemical and different power plants, refrigeration systems are being used. In medical uses, for example, for the transportation of organs and for different vaccines. So these are the few important application of refrigeration system. So what is refrigerant? Refrigerant is actually a cooling agent that is used for the refrigeration process in different refrigeration system. So this is actually a fluid that is used for producing cooling. So it has different nomenclature. The first one is prefix, the second one is suffix, and the third one is isomer. So, for example, when we are studying the refrigerant like R134A, so R is actually the prefix, the number 134 is the suffix, and A is actually the isomer. So, saturated hydrocarbons are also used for different refrigeration systems. Most of the refrigerants are driven from hydrocarbons. So as I have already told you, the R stand for prefix. These numbers 22, 12, 134, and 410 are the suffix, where alphabets A and C are the isomers. Here are the different types of refrigerants. For example, the refrigerants that contains the different halogens and halocarbons are known as the primary refrigerants, where secondary refrigerants are liquids, normally water and this brine solution. So there is no phase change in the secondary refrigerants. These are the two main different classifications of the refrigerants. Primary refrigerants are the refrigerant which cool the substance or space directly by absorbing the latent heat. So when we will discuss about the vapor compression refrigeration cycle, then we will also discuss about the different refrigerants clearly, how they will absorb the heat in evaporator and how they will reject the heat in condenser, because when we are studying the vapor compression refrigeration cycle, there are different components that perform different tasks for performing the refrigeration process. So, in primary refrigerants, phase changes occur, and there are the different types of primary refrigerants. For example, halocarbon refrigerants, isotope refrigerants, inorganic refrigerants, and hydrocarbon refrigerants. These are the different types of primary refrigerants. In halocarbons, the three main halogens, chlorine, fluorine, and bromines, play an important role for the bonding of hydrogen and chlorine and fluorine for producing the better thermal performance of these refrigerants. Isotope refrigerants is actually the combination of two different refrigerants, and they cannot be distilled after performing the distillation process. So inorganic refrigerants are the refrigerants that has different bonds without chlorine and fluorine, and hydrocarbon refrigerants are the refrigerants that contain hydrogen and carbon. So these are the primary refrigerants that are used for the cooling process in different refrigeration systems. When we will discuss about or talk about the second refrigerants, so these different refrigeration systems are the liquids which are transporting thermal energy from one location to another location. There is no phase change. For example, brine solution. When we will discuss about the vapor absorption refrigeration system, we will also study these secondary refrigerants, because vapor absorption refrigeration system use secondary refrigerants. So in vapor absorption refrigeration system, we will also discuss about the secondary refrigerants. Here are the few diagrams of the refrigerants. This is R22, this is R12, and this is the cylinder of R12. And R22 known as monochlorofluoromethane, trichlorofluoromethane R11, and R12 is dichlorofluoromethane. There are the different types of compression, refrigeration, and absorption refrigeration systems, and this is the difference between vapor compression and vapor absorption refrigeration system. So, as we can see, there is a word of compression. So, the main difference between vapor compression and vapor absorption system is the presence of compressor in the cycle. So, when we will discuss about vapor compression refrigeration system, as I have already told you, the primary refrigerants are used for vapor compression refrigeration, and the secondary refrigerants are used for vapor absorption refrigeration systems. So chlorofluorocarbons, CFCs, hydrochlorofluorocarbon, HFCs, and hydrochlorofluorocarbon, HCFCs are used for vapor compression refrigeration systems. The compression of the refrigerant is done with the help of compressor, and vapor compression refrigeration systems takes in high grade energy such as electrical or mechanical energy for operation of the compressor used in the cycle. And the COP stands for coefficient of performance. We will also discuss about the coefficient of performance, because COP is actually a ratio between two different inputs and outputs. For example, for the refrigeration process, the cycle is actually started from compressor. So the work done by the compressor will be the input, and the output is actually in the form of cooling. So the refrigerating effect will be the output. So the relation between the output over input is actually here known as the coefficient of performance. Means the COP is actually a ratio between the refrigerating effects over the work done of the compressor. We will also discuss about COP in our upcoming few slides. Vapor absorption refrigeration system. Water, ammonia, or lithium bromide is used as a refrigerant, or in the vapor absorption refrigeration system, the compression of the refrigerant is done by absorption of the refrigerant by the absorbent. So there are two different types of fluids used for vapor absorption refrigeration system. The first one will be known as the absorbent, and the second one is known as the refrigerant. So the process of compression is done with the help of absorption of the refrigerant by the absorbent. Here is compression actually done with the help of compressor. Vapor absorption refrigeration system takes in low grade of energy like waste heat from the furnace or exhaust steam or solar heat for its operation. So the COP of the system is poor because the low grade energy is actually used as the input for the furnace. So this is the reason for the low COP of this cycle system. Here you can see this. This is a basic refrigeration cycle. You can say this is a vapor compression refrigeration cycle that is used for vapor compression refrigeration system, and here is the working diagram. This is the compressor, this is condenser, this is expansion valve, and here is the evaporator. So the process starts from compressor. Compression is done with the help of compressor that rises its pressure and temperature. So the refrigerant is compressed by the compressor, increasing its pressure and temperature. Then condenser will perform the process of condensation. Condensation is actually performed with the help of condenser, where the high pressure refrigerant release heat and condenses into a liquid in the condenser. Here is the expansion valve. So for expansion, the refrigerant passes through the expansion device where its pressure drop and cooling it further. Here is evaporation. The fourth stage of vapor compression cycle is known as evaporation. So evaporation is performed with the help of evaporator, and the refrigerant absorbs heat from the surrounding in the evaporator, turning back into a gas to the refrigerant. So the heat is actually absorbed from the surrounding. The substance which needs cooling, refrigeration in the confined space will release its heat, and that heat will be absorbed from the refrigerant. And after absorbing the heat from the substance, the substance is actually resulting for the cooling mechanism. So after evaporation, the refrigerant returns to the compressor and cycle repeats. There is vapor absorption refrigeration system. So जैसे कि हमने पहले डिस्कस किया कि वेपर कंप्रेशन रेफ्रिजरेशन सिस्टम में जो कंप्रेशन का काम कंप्रेसर कर रहा है उसकी रिप्लेसमेंट यहाँ पे होती है इन द फॉर्म ऑफ एब्जॉर्बर. This is actually absorber. Here absorber will be, this is the diagram of ammonia and water, जिसके अंदर अमोनिया जो है वो एज ए रेफ्रिजरेंट यूज हो रहा है और वाटर जो है वो एज एब्जॉर्बेंट यूज हो रहा है. तो यहाँ पे हमारे पास पंप है, ये एब्जॉर्बर है और ये वेपर जनरेटर है जो वेपर जनरेट कर रहा है अमोनिया के हाई प्रेशर पे. बिकॉज इसका लो बॉइलिंग पॉइंट है तो इजीली ये इवेपोरेट हो जाएगा. आगे इसके अंदर हीट एक्सचेंजर के अंदर, दिस इज हीट एक्सचेंजर वन, here is the heat exchanger 2. So 1 is actually known as condenser and heat exchanger 2 is performing like a evaporator. And between these two heat exchangers there is an expansion valve that is known as throttle valve. So जब यहाँ से अमोनिया evaporate होता है because ammonia has low boiling point as compared to water, तो वाटर उधर ही रहता है और वापस चला जाता है एब्सॉर्बर में. और after passing from condenser, expansion valve and evaporator, these ammonia vapors will will be in the form of gas after releasing from the evaporator, और ये दोबारा एब्जॉर्बर में आते हैं. यहाँ पे लीन मिक्सचर दोबारा रिच मिक्सचर में कन्वर्ट होता है और स्ट्रॉन्ग अमोनिया सोल्यूशन पंप करता है इवेपोरेटर जनरेटर को, जहाँ पे अगेन इसके नीचे एक फर्नेस है जो इसको स्टीम देती है और यहाँ से इसको हीट मिलती है. हीट को एब्जॉर्ब करता है इन द फॉर्म ऑफ लेटेंट हीट. सो यहाँ पे जब अमोनिया इवेपोरेट होता है तो दिस विल एक्ट एज अ रेफ्रिजरेंट, और ये साइकिल बहुत बार चलता रहता है। हियर इज अ वीडियो ऑफ वेपर एब्जॉर्प्शन रेफ्रिजरेशन सिस्टम, जो जिसमें आप देख सकते हैं जो रेड पार्टिकल्स हैं वो बेसिकली अमोनिया के हैं, और जो ये ब्लू पार्टिकल्स हैं ये लिक्विड है इन द फॉर्म ऑफ वाटर। सो एब्जॉर्बर के अंदर से अमोनिया के वेपर्स को एब्जॉर्ब को एक्सट्रैक्ट करवाया जाता है एब्जॉर्बर में। एब्जॉर्बर्स को हीट मिलती है, सॉरी, एब्जॉर्बर से पंप के थ्रू ये सोल्यूशन जाता है हीट एक्सचेंजर में, जिसके नीचे फर्नेस है, उसको हीट देते हैं, और लो बॉइलिंग पॉइंट वेपर्स, जो अमोनिया के वेपर्स हैं वो हीट जैसी उनको मिलती है तो लो बॉइलिंग पॉइंट है, वो इवेपोरेट्स हो जाते हैं। और वाटर चूंकि हाई बॉइलिंग पॉइंट है, 100 पे बॉयल होता है, तो वाटर वाटर जो है वो मिक्स मोड में वापस आ जाता है, जबकि वेपर्स आगे मूव होते हैं। यहाँ पे हीट एक्सचेंजर 1 है जहाँ हीट रिलीज होती है, एक्सपेंशन है, मजीद कूलिंग होती है, लिक्विड फॉर्म में एवेपोरेटर में आते हैं, इर्द गिर्द से हीट जज़ब करते हैं, गैसियस फॉर्म में अगेन एब्जॉर्बर में चले जाते हैं। तो ये प्रोसेस है वेपर एब्जॉर्प्शन का। अब यहाँ पे जो काम हाई प्रेशर और हाई टेम्परेचर का हो रहा है, दैट इज एक्चुअली परफॉर्मिंग with the help of three different sources. The पंप प्रेशर के लिए यूज हो रहा है, यहाँ पे हाई टेम्परेचर के लिए फर्नेस यूज हो रही है, और एब्जॉर्बर उनको मिक्स कर रहा है। तो ये तीन प्रोसेस इसके प्रेशर और टेम्परेचर को इंक्रीज कर रहे हैं, जबकि वेपर कंप्रेशन रेफ्रिजरेशन सिस्टम में ये जो सारा प्रोसेस यहाँ पे तीन डिफरेंट कंपोनेंट्स कर रहे हैं, वहाँ पे अकेला कंप्रेसर कर रहा होता है। So what is turn-off refrigeration? Turn-off refrigeration is actually the rate of heat release from 1 ton of water in 24 hours by reducing the temperature of water at 0 degrees centigrade, and the heat that is used to perform this process, the heat used for 24 hours is 3.5 kilowatt. So 1 ton of refrigeration is equal to 3.5 kilowatt. So 1 ton of refrigeration is defined as the quantity of heat removed to freeze 1 ton of water into ice at 0 degree centigrade in 24 hours. मतलब 24 घंटों के अंदर 1 टन वाटर में से कितनी हीट, लेटेंट हीट रिलीज हो कि उसका टेम्परेचर 0 हो, और वो हीट है 3.5 किलोवाट, तो इसको हम कहेंगे 1 टन ऑफ रेफ्रिजरेशन। इन BTU दिस इज इक्वल टू 1200 BTU। कोएफिशिएंट ऑफ परफॉर्मेंस, coefficient of performance is known as the ratio between the cooling effect or refrigerating effect over work done. So it is defined as the ratio of heat absorbed in a given time, means the refrigerating effect to the work done. So refrigeration effect performed at the place of evaporator, and the work done is actually done at the stage of compression. So input will be in the form of work done, and the output will be in the form of cooling effect or refrigeration effect. This is the pH chart. pH chart is used to calculate the work done by the compressor, the heat release from the condenser, the refrigerating effect of vapor compression refrigeration system। उसके लिए हम pH चार्ट की मदद से भी यूज करते हैं, क्योंकि pH चार्ट के ऊपर आपको प्रेशर की वैल्यू मिलती है, इंथैल्पी की वैल्यू मिलती है, और आपके पास डिफरेंट फार्मूलाज हैं, उनके अंदर आप इन वैल्यूज को यूज करके कोएफिशिएंट ऑफ परफॉर्मेंस निकाल सकते हैं। pH चार्ट की अगर इस लाइन की बात करें तो ये सैचुरेटेड लिक्विड लाइन है, दिस इज सैचुरेटेड वेपर लाइन, दिस इज द सुपर हीटेड वेपर रीजन, दिस इज द liquid plus vapor region, and this is the liquid region। यहाँ पे एक आपको साइकिल नजर आएगा, प्रोसेस 1 to 2 इज द वर्क डन बाय द कंप्रेसर। सो हेयर इज आइडली द प्रोसेस इज नोन एज आइसेंट्रोपिक। सो द कांस्टेंट एंट्रोपी लाइंस के पैरेलल आप एक लाइन ड्रॉ करते हैं दैट रिप्रेजेंट्स the isentropic process of the compressor in the form of work done. So heat release will be performed in the form of constant temperature. This is the isothermal lines. These are the isothermal lines. So from process 2 to 3, heat is released. Process 3 to 4, the expansion is performed, and process fourth one is evaporation. So evaporation के अंदर क्या होता है कि आपकी हीट ऐड होती है रेफ्रिजरेट के अंदर और इर्द गिर्द की एशिया को आप ठंडा करते हैं. सो यहाँ पे आपको मिलता है रेफ्रिजरेटिंग इफेक्ट. So what will be the formula for refrigerating effect? H1 minus H4. What will be the formula for work done by the compressor? H2 minus H1. Heat release from the condenser will be equal to H3 minus H2. And the refrigerating effect or evaporation done with the help of evaporator. और जब आप refrigerating effect को find करेंगे या cooling effect को, that will be H1 minus H4. इन लाइंस को आप एक्स एक्सेस के ऊपर रीड करते हैं और यहाँ से आपको इंथैल्पी की वैल्यूज मिलती हैं. उन वैल्यूज को यहाँ पे H2 में, यहाँ पे अगर आपके पास इंथैल्पी की वैल्यू फॉर एग्जांपल 300 है तो H2 विल बी 300 एंड H1 की वैल्यू फॉर एग्जांपल 240 है. सो H1 विल बी 240. सो द डिफरेंस बिटवीन 300 एंड 240 इज द 60. सो 60 किलो जॉल पर केजी विल बी द वर्क डन बाय द कंप्रेसर. सो इसी तरह आप H1 - H4 से भी निकाल सकते हैं. आप H1 - H4 से रेफ्रिजरेटिंग इफेक्ट निकाल सकते हैं एंड H2 - H3 से आप हीट रिलीज बाय द कंडेंसर आप निकाल सकते हैं. So what are the environmental effects? So refrigeration system actually rely on refrigerants, and there are different types of refrigerants. कुछ refrigerants जो हैं वो environmental friendly होते हैं और कुछ environment को pollute कर रहे होते हैं. जैसे कि हम पहले डिस्कस कर चुके हैं, there are different types of primary refrigerants. For example, halogen refrigerants, halocarbon refrigerants, hydrocarbon refrigerants. So these refrigerants actually cause for pollution in the environment. जैसे कि हमारे पास ओल्ड रेफ्रिजरेंट्स थे, R12, R22, वो भी इन्वायरमेंट के अंदर पोल्यूशन क्रिएट करते हैं. सो डिपेंडिंग अपॉन द थर्मल फिजिकल एंड थर्मोफिजिकल प्रॉपर्टीज ऑफ द रेफ्रिजरेंट एंड द केमिकल प्रॉपर्टीज ऑफ द रेफ्रिजरेंट्स, इन्वायरमेंट को पोल्यूट भी कर सकते हैं. एंड few refrigerants are environmental friendly. For example, the modern refrigerants like R410, etc. So the refrigeration system relies on the refrigerants which have environmental impacts, such as जो environmental impacts होते हैं जैसे R12 और R11 का मैंने आपको बताया, R22 का बताया, वो impacts होते हैं in the form of ozone depletion and global warming pressure. और मतलब आपका जो स्ट्रेटोस्फेयर है वो जहाँ तक इफेक्ट हो रहा है उसके अंदर जितने भी आपके impacts आ रहे हैं वो environmental impacts कहलाएंगे. The shift towards eco-friendly refrigerant, for example, R134A or 410A, and natural refrigerants will reduce the environmental pollution.